hysterical about technology. Wolfram Alpha, though, write it down. It's good. And you would have loved to have known about it during upgrading.
Yes.
Like that would have been like it's your debugger for math in upgrading and just math in general, where you're like, did I do this right? I don't know, and you just look it up. Anyway, sorry, we'll get started. So I don't have any announcements other than we have a quiz today. It's still a take home. I guess, so I've had enough students ask me this. It is open book entirely, open notes, whatever. You can use whatever you want. What I was just discussing is you can use ChatGPT to try to help you if you want, but that's a really terrible idea. I describe it as hammering in a nail with a screwdriver. You are using the wrong tool for the job. Can you do it? Well, yeah, if you stand there for long enough with the screwdriver, it'll get that nail in, but there are way better tools. One of them is called Wolfram Alpha. I am going to have a lecture where I talk about it a little bit for like helping with math. It is the right tool for that job. It's built on Mathematica with an AI engine, so it's a very glorified calculator. But when you're working on math, that's what you want, right? You want a fancy calculator. You don't want fancy Google. You want fancy calculator. So that's just using the right tool for the right job. That's what I was talking about. But last class we did logic, quote unquote, algebra rules. So I had like a whole table of them. I've actually posted it on Blackboard now. It's just, there's a separate link that's just, here's all the rules. So now you can have it handy. So like, especially when you're working on the exercises, you just have it available, right? You do not have to, dig through my notes to find all of them or dig through your notes. I just put them there. You can just look at them. We also had these quantifiers. So that was for all x and there exists an x such that. And we had De Morgan's laws. So these were the ones that said negation distributes over brackets, except you have to switch the symbol, right? Like that. So that's what De Morgan's law said. And there was another one for the equivalent when you switch it. So today, what we're going to do is we're just going to go through some examples of using these algebra rules, because they're essentially, well, it's algebra, right? And a lot of it matches familiar algebra rules from high school or before. So I figured, hey, let's just do some examples of it so we can get comfortable with it. So simplify the expression what do I have? Not P or Q and not Q and P. Okay, so I know simplify is a bit of a misnomer. I don't like that word, but for this, it's usually pretty obvious. It's condense it down as much as possible, right? So on assessments, I will generally say simplify it to get to this, right? So rather than you just going on a goose chase and then saying, is it simple enough? I don't know yet. Have I gone far enough? I will explicitly tell you, you can stop here, right? And that would be like, you've simplified it enough. The reason why I walked in here at exactly 6 is on this quiz, I wrote that, but I had about half the students come up to me and they had an or, which does not match what I have written down here. But then half of them came with an and I was like, did I make a typo? Oh, no. So on this one, I'm going to be like, generally with this, I'm very generous, right? Because it's about using the rules, right? It's about manipulating these expressions. It's not about the correct answer in this case, right? If you have manipulated the expressions and you have used the rules, like you've used the distributive law, you used De Morgan's, you messed around a bunch, I'm like, hey, good job, right? That's what I was looking for. Getting practice with the rules, getting practice with some algebra, and trying to get to what I said you should get to. So what I mean here is, let's take a look at this example. Our goal is to shrink this down, right? To use rules to make it smaller or more condensed. So generally speaking, one of the first things you can look at is, do I have a negative outside of some brackets? Because if you do, you just use De Morgan's laws real quick, it's going to simplify it a little bit. So this one is a perfect example of that. Because what this is going to say is, take what we have here, put this negative in, and flip this symbol. All right, so the and becomes an or, and we're going to put not in front of both of these. That's what De Morgan's law says. Okay, well now we have this right here, which is not Q, right? Which works like math, right? This is double negation. And those essentially just cancel out, right? And sometimes people will do that in your head, and if you can, that's fine. If you want to write it down, that's also fine. So this not Q is just going to become Q, or not P. Okay, well this thing here and this thing here, they look almost the same, right? They're just written in a different order. Fortunately, we have a rule that says, hey, around ors and ands, you can swap the order of stuff. So we can turn this one into Q or not P. Like that. Okay, and now what we essentially have here is we've got this statement here and the same thing again, right? This is just repeated around this and. So what we've essentially got is P and P, so something and the same thing again. What can we simplify this to? If we think about it, this isn't like a rule. This is just thinking about truth tables and logic and that sort of thing. So we have P and P. What could we write down instead to simplify that? Yeah, exactly, right? Because in this case, it's P and P, so the truth value just depends on P, right? P determines it. So that means this thing here, we basically just get rid of one of these, right? Because this, yeah, it's more complicated than P, it's bigger, but the point is it's this thing and the same thing, right? So P and P becomes just one of those, right? We just replace both of them with one of them. And of course, we don't really need these brackets at this point. So we see we started with something a little bigger, and in this case, simplify is quote unquote obvious, right? We want to reduce it down as much as possible. So there's, I don't remember the logic word for it, something normal form, where it only involves one of the letters, right? So we have one Q and one P. We started with a P and a Q as our input, but you see it appears multiple times here. But we can always simplify it down to just being one of each somehow. It might be a little ugly, but we can do it. But we see the most common things that we'll end up doing are using these De Morgan's laws and double negation and flipping stuff around and just trying our best to work with it. Okay, let's just do another one. Yeah.
Can you just tell me the De Morgan? So which sign we have to reverse?
It's this one right here. So this is an and becomes an or.
Okay.
Yeah.
And what about that one before negation?
This one?
No, the other one.
This one?
Yeah.
That stays by itself because it's sort of before the negation,
Okay.
right? So it's only stuff inside of the brackets that we have to worry about.
Okay, so if we take the negation inside the bracket, then we reverse the sign.
Yes.
Okay.
Yeah. So only when we bring this inside of brackets do we have to worry about that. Okay. I'm gonna write this down. Simplify the expression Q and not P or not R. A lot of brackets here. Or P, which a lot of brackets also usually makes it pretty clear what we mean by simplify, right? We got a lot of brackets, let's get rid of brackets, right? As best we can. Okay, so we've got that same situation happening here. We have negation outside of some brackets. So our first instinct is let's distribute that in with De Morgan's law. Simplify that. So what do we get? Well, this goes in, becomes not P, we flip that symbol, and we get not R. So that's this again. You could write it down and do it in another step, but in this case, I'm just going to do it in our head. We're going to say not R, the knots cancel out, and we just get R or P. Okay, so this is where things there's a couple of ways to do this. It's a little messy, but we can distribute now. So notice I'm gonna write with different colors here. So this is P or something and something else. So this symbol is different from that one. So we can use the distributive law. And this is where it's a bit ugly, but this happens sometimes when we're using these rules. This is something in brackets, but it's still just a formula, right? So we can distribute to it. Think of it like this. This is X, Y, Z. So this is X and Y or Z, where Y is a more complicated thing, but we know what to do with the distributive law here. This is just X or Z and Y or Z. That's what the distributive law tells us. So, okay, what's our X? It's Q. Or what's our Z? P. Okay, great. That's easy. And Y, now this is the thing in brackets, right? This is the more complex looking thing. Not P and R. Or P. Just because it's more complicated in the brackets, it's fine, right? It's still just a formula. We can still just do this exactly the same. But now we see here, we've got the same thing. An or with an and. So we can distribute again. So this time, I'm going to distribute into the blue. So this guy here stays by itself. Got not P or P. And then we've got R or P. Oops. Like that. Okay. So now, what could we do next to simplify this a bit? Does anything jump out as maybe we could remove it or move it around or simplify it? Which one? Sorry, no, but I mean, you might have the right idea.
No, I thought the P was an R.
Oh, okay. Yeah, fair.
Can we put P in the outside or pre?
So we could, but that just puts us back to square one. That's sort of what we just did, right?
I was gonna say, isn't not P or not P or P always true? So you can just
Yeah,
then try
exactly. Yeah. So that's a good one. So that's one thing we could do. We've got not P or P. That's always true, right? Because if P is true, then not P is false. So who cares? The whole statement is true. If P were false, then not P is true. So the whole statement is true. So this thing here is always true. So that means we can write Q or P and true and R or P. But anything and true, we basically can just drop this true, right? If we think about it, P and something that's always true is just P, right? Because if P is true, then P and T is true. If P is false, then P and T is false. So this only depends on P, right? This T doesn't end up mattering for this statement. So it can be helpful when because this also isn't a rule. We're just sort of thinking logically, okay, well, how does this work? If we just think in terms of a truth table, right? We have P, T, which is always true. And then we have P and T, right? T and T is T, F and T is F. That's the same thing as P, right? We can kind of see this matches that, right? So in terms of truth table, these are the same thing. That's another way that you can argue. If you have something that has the same truth table as something else, you can replace them with each other, right? That's the truth table is what dictates whether or not they're the same thing. So the point here is that means we can just basically cross that out. We don't care about it anymore. Q or P and R or P. Now at this point, this is looking pretty good, right? We've condensed a lot of our brackets here. Things are looking pretty squished down. There is one more thing we can do, and this is something that is tricky for especially starting out with this sort of stuff. And if it's been a really long time since you've done algebra, we can essentially use the distributive law in reverse, or you could say we can factor out an or P if you want to think of it that way. So what I mean is, let's just think we're used to doing this. I'm actually going to write it in the same order as that. Right, we've got this in math. We're used to distributing this and getting y times x plus z times x. Right, this is something we're used to doing with numbers, right? We can also do it the other way around, though, right? If we had x, I'm going to use y again, actually. xy plus zy, right? We can factor out the y, right? We can pull that out and simplify this to x plus z times y, right? Sort of going in reverse. This is the same thing. We can do that here too. So we just have to think, what are our distributive laws here? So we've got, well, I think it would normally be written as Q and R or P, right? This is looking like a distributive law, right? This thing is the different sign from this. Would normally look like Q or P and R or P. Like if you just took the distributive law from the notes, it looks like that, right? Right now we actually have this written down, right? Q or P and R or P. But these are the same thing. So that means we can replace this with the simpler looking one in some sense. So this is distributive again. In reverse to get, well, right there, Q and R or P. And now every letter only appears once, right? P, Q, R. Here we had P appearing twice and lots of brackets and messy stuff like that, but we see we've condensed it down to just like one single statement. I would say if you got like let's say this were an assignment question. You didn't get to this. You got this far. The difference between 4.5 and 5 becomes statistics. If everyone except you got to here, I'd be like, damn, sorry, gonna dock 0.5. Everyone else got it. But if most people didn't make it that far, if most people got here and were like stuck, I'd be like, that's as far as most of the class got. So then, you know, maybe this was a bit too, maybe it was a weird trick, right? And that like if most people didn't get that far, I'd be like, okay, this is worth 5, and maybe I'll give a bonus half mark or something like that, right? Like that's the distinction, right? If everyone struggled with it, then I'm generous. If nobody struggled with it, then I have to be like, I gotta be a bit of a dink about it. But most of the time, when something like that happens, it's almost something to know about math, which I'm sure is your experience is talking to people in math classes, is one of those never happens. There's never a situation where it feels like it, because I've taken math classes, shocker. It feels like you're the only person in the room who doesn't get it sometimes. Like you look around and you're like, everyone seems to understand that except for me, right? Like I'm the one who doesn't get it. That is almost never the case. It's usually the opposite. It's everyone else is also doing exactly that. Everyone is like, wait, what's going on? And so then that means everyone is in this position, which means everyone's going to get 5 out of 5 for going that far, right? Is kind of what I'm getting at. But we look at this, and it's just about applying these rules sort of in order to solve a puzzle, right? Especially if you know in advance what the goal is. If I had opened this with simplify the expression blah to this, then you'd be like, okay, well, I'm trying to get here. What steps do I need to get there? But sometimes knowing the final solution can be a red herring, because sometimes there are multiple ways to get there, and knowing the final solution might make you do things that are not obvious immediately, or maybe are tricks that lead you down a much more complex path than just the maybe slightly longer but more obvious way, right? So usually for these simplify things, there's many, many, many ways to tackle the problem, and some of them are better than others, and I will never discourage you from doing one way unless you're trying one way and you're like, I'm at my wit's end. This just not working. And then I'll be like, okay, we'll try this instead. Because I don't like telling someone your idea is wrong unless it is explicitly wrong. Like if it's just another way to get to the same destination, I'm gonna be like, yeah, keep going. Like that's clearly what you thought of trying. So let's roll with it, right? Let's keep going with that idea. If that idea is completely wrong, I'll be like, no, this is why it's not going to work. Try this instead. But yeah, there's just multiple ways to get there. So, I could invent another one to go through another example if people want. I could also just give you the quiz and say go nuts. How do we feel? Do we want to see another one?
What if you don't understand any of it?
Then I can answer questions for you one-on-one. Does that sound good?
Yeah.
So quiz then, and then I can just walk around and help people. Okay, we'll do that. So one thing I do want to